is, given a post-order representation of a mathematical equation, output the result. Assumptions with this problem are that the only operators we'll be dealing with are the addition, subtraction, division, and multiplication operators. All numbers will be integers, and they can be negative. There will always be the exact number of operators needed to deal with the number of integers in the array, and we'll never have to worry about dividing by 0. So for a quick example, let's say we had an array of size 3. The first element is 3, the second element is 7, and the last element is the addition operator. This would output 10, because 3 plus 7 is 10. So now for my algorithm, I'll start with the signature. So we're returning an integer, so public int. I'm going to call it post order math. And then we're passed in an array of strings. So I'm going to call this EQ for equation. Okay, now we have the signature. So the first thing I want to do inside the method is initialize one stack and one queue. So the stack, I'm going to call nums. Because it's going to be responsible for holding all of the integers we'll be working with in the mathematical equation. And then the queue, I'm going to call ops for operators. So this will be responsible for holding all of the operators we're dealing with in the equation. And it may also hold some numbers depending on the order of operations of the post-order representation of the equation. So now I have my stack and my queue. The next thing I want to do is create a for loop, and I'm going to iterate through the entire EQ array. So I can put the correct characters, or the correct elements of the array in the correct data structure. So I'm going to create a for loop. I'm going to call the incrementing variable I. Start at 0. So while I is less than the length of our array EQ, we're just going to increment I by 1. So inside the for loop, the first thing I want to do is check if the character at position I in the array is an operator. So if EQ at position I is equal to plus or minus or multiplication or division. And I know that's not correct syntax, I'm just trying to save space. So if it's one of these, we're just going to add them to the ops queue so that they're contained in the correct order of operations. So now if it's not an operator, we're dealing with the integer. So in this else statement, I want to check if our queue ops is empty, because that means, actually, let me finish writing this. So I'm going to check if our queue is empty, and if it is, I'm just going to push the integer onto the nums stack. And the reason for this is because if we've already added a operator to the queue, we don't want to push another number onto the num stack because that will mess up the order of operations. So what we're going to do is if an operator has been added, so the queue is not empty, we're just going to add that number onto the queue instead, so that we can push it. When it's the right time, we'll push it to the num stack, but for now, we'll just keep it in operators. Okay, so now I've finished my for loop, and hopefully everything is in the correct data structure. The next thing I want to do is start constructing the result. So I'm going to create a while loop, and I'm going to say while nums is the size of our nums stack isn't equal to 1. And the reason I'm saying this is because when everything is said and done, if there's only one thing left in the stack, that's going to be our result, and that's what we're going to be our return. So we're just going to quit out of the while loop and return that, the top of the stack. So inside this while loop, I'm going to create another while loop. And it's going to be similar to this conditional statement. So while ops.peak, which we'll look at the top of the queue, is not equal to plus or minus or the multiplication operator or the division one. So this is so this is checking if the top of the queue is not a operator. We're just going to push it. We're going to remove it from the queue and then push it onto the num stack so that the numbers are in the correct. We can then deal with the numbers in the correct way with the correct operators, keeping the right order of operations. So I'm going to do nums. We're going to push what we removed from the queue onto the num stack. So nums.push ops.remove, and this will just get every number that's at the top of the queue before we get to an operator. So now hopefully we've dealt with all the numbers that are in our that are at the top of our operators queue. The next thing I want to do is so I'm going to set a character variable. I'm going to call that oper for operator. And I'm going to, again, remove the top of the queue, which should be a operator this time, not an integer. So now what I want to do is create a big if-else statement. So if oper is equal to plus, we're just going to add the two. So if the character is the addition operator, I'm going to create two integer variables called num1, and then we're going to pop a number off the stack, and I'm going to create another one, num2, and again we're going to do the same thing, just pop the next number off the stack. So this will get the two top numbers off the stack in the correct order that we're dealing with them, so that we can perform an operation, in this case the addition one. So I'm going to do num2 plus num1 because num2 will be the first number we're dealing with. Num1 will be the second one we're dealing with if we're talking about popping things off the stack. So num3, actually, these are both strings, so I just want to do 2i, put that in here, string 2i. Sorry, I messed that up. But this will convert them to integers, and then we're going to perform the operation here at num3. So we're going to do num2 plus num1, and then we're going to push our result back onto the num stack. So nums dot push, and then this is an integer, so we're gonna have to reconvert it to a string. So in integer to string nums3 or num3, and this will allow us to continue with our mathematical equation as we build our result. So this was for plus. I'm just going to do the same thing over again for minus, multiplication, and division. Hopefully I have enough room. It's going to take a while. Nums dot and then num3 this time using subtraction, and then we're going to push this again. Nums push. We're going to push the result we get in nums3, and again use integer toString. Okay, I'm going to move right here because I've run out of space. So now we're on multiplication. So else if multiplication, else if operators equal multiplication, we're just going to do the same thing one more time, or another again. So in nums1, it'll string 2i, or num1, 2i nums dot pop, in num2, string 2 integer, again pop, then our result integer is num2 times num3, and then we're just going to push the result again onto our stack. So integer toString num3, and we'll just do this one more time for our division operator. So else and then one last time, num1 string to integer, we're going to pop top of the stack. Do it one more time for the second integer. And then we're going to create nums3 one more time to get the result, which is just going to be num2 divided by num1. And then we're going to push num3 onto the stack, just like I've done the last 3 times. And then, so now we've handled all of our operators. So now once we get down to the stack of size 1, we're just going to quit out of the loop, and we're going to create an integer, and we'll call it res for result. And that's going to be equal to string to integer of nums dot top, which should just be our result at this point. And then we just return the result, or res. And that should be the algorithm. So for the runtime, this runs in O of n time, so we'll run the length of the equation once here, so n, and then the stack will, when computing the result, will go another n times for the stack, and then there's another while loop inside this while loop, but that's just going to be shifting around some numbers, so I don't think it'll be going through n times, so we'll just call it like m. So the highest order term for this algorithm is just n, so our time is O of n time. As for space, we're storing, so we go through the entire loop, and we keep track of the stack, we keep track of the queue, which is going to store n things, so our storage is also, or our space is also O of n, because we're just going to be shifting around our data and storing them in different data structures. So lastly, I want to go over like a quick example. So why don't we do the one, or I'll do the one I did in the beginning. So we have an array of size 3. So it's 3, 7, and then a plus operator. So we pass this into the algorithm. So we create our stack, we create our queue, and then we're into the for loop. So if the element at position I in the eq array is equal to an operator, which is not, we skip over that. We check if the queue is empty, it is, so we just push 3 onto the stack. Go through the for loop again. We check if 7 is an operator, it's not. So we quit out of the if statement, we go to the else statement. Again, we check if operators is empty, it is, so we push 7 onto the num stack. And now for the last element of the array, we're going to again check if it's an operator, it is, so we add it to the operators queue. Now we're going for loop, now we're going to construct our answer. So while nums.size is not equal to 1, so now we're going to check if the top of the operator's queue is not an operator, which it's not, because we only have the plus sign in there. So we skip over this while loop. Now we pop off the plus operator into the operator character variable. So now down here, we check if operator is a plus character, which it is, so we get num1, which will be 7, which was converted to, the string was 7, which we converted to 7 through the string.toI method. We pop off the second number, which is 3, and then we add 7 plus 3, and that's our num3. We push that onto the stack. So now we're going to go through the rest, and it's going to go up to the while loop again, see that, or it's just going to ignore the rest, go back to the top of the while loop, see that size is 1 of the num stack, it just contains 10, because 7 plus 3 is 10, so it contains 10. jump out of the while loop, and where is did I erase it? Just erased it. But so we have our result. Anyway, so we have a result, which is just going to be the top of the stack, which is 10. So we're just going to do string.toIve one last time. And we're just going to pop the top off the num stack, which is just our result. Which is just going to be our result 10, and then we're just going to return result, which is 10. So we got the correct answer. And that's the algorithm.